All right. Our first speaker, Kakani Katija, is a principal engineer at MBARI, where she leads the Bio Inspiration Lab. Can we please play Kakani's video?
Hi everyone, my name is Kakani Katija, and I'm a principal engineer at the Monterey Bay Aquarium Research Institute. I'm really excited to be able to join you all today and share with you some of our activities in my lab, the Bio Inspiration Lab. And specifically, we develop technologies for studying biological phenomena in the deep sea. And we do this primarily by developing technologies related to imaging. And our start has been focused on imaging or instrumentation that could be integrated onto larger robots like the remotely operated vehicle you see here. And the first instrument is DPIV. It's a laser-based imaging system that enables the quantification of animal fluid interactions. The laser will actually scatter off of media, either particles or bubbles in the water column, and we can then capture those motions and use those motions as a proxy for fluid motion. DPIV has been really valuable. It provides planar measurements though, and so we started looking at systems that allow us to do volumetric reconstructions. And so Moore Foundation has funded us to look into light field or planoptic imaging to do just that. And so this instrument is called IRIS. It's a system that enables the quantification of three-dimensional particle fields, but also moving structures. And while this system has been integrated on remotely operated vehicles first, it will be integrated on autonomous underwater vehicle next spring. I think what's been really interesting though to me about this whole process is the surprising ways in which you can use this technology once it's been developed. And that really can be described by using DPIV, where, while it was originally designed to do particle, animal fluid interactions, what we've been able to show is that using it in a scanning mode, we can reconstruct structures that are either made out of gelatinous material or mucus. And so what you're seeing is the interior view of a giant larvation mucus house, where each of these channels show very real complexity, and we're working with animators and other CGI artists to try and create these models, as well as make them available to the public so people can understand what the ocean world inhabits, right? Who inhabits it. Besides that, we've been heavily involved in the Mesobot project. So this is a project that's been funded by the National Science Foundation. It's funded a number of different researchers led by Adana Yerger at Woods Hole. We've been working predominantly on integrating imaging or stereo imaging with vehicle tracking algorithms so that we can autonomously track underwater targets for more than 24 hours. And so this is a video of a Mesobot in MBARI's test tank facility from last summer. And one of the things we've learned through this process of algorithm development is that, in the ocean, especially even in the midwater, there's a very noisy visual field. And it's not uncommon for multiple animals to be in the field of view, crossing each other, thereby disrupting tracks. And so because of this frustration, we've been looking to other techniques, particularly machine learning, as it provides an opportunity to automate the detection as well as classification and distinguish different features in imagery and video. And so that's part of the reason why we've started Fathomnet. And this is a project that was born out of the Here Be Dragons event that was hosted at MIT Media Lab by Katie Croft Bell in 2018. And so Fathomnet is an image training set that is heavily borrowing from MBARI's video annotation and reference system database. So the idea is that if we can pull from historic images that have been annotated and add localization information like these bounding boxes you see here, we can create a database then that data scientists can use to train up machine learning algorithms to automate the detection and classification of objects in underwater imagery and video. And the database should be released by the end of the year, which is really exciting, one. But what's also been really exciting is that we've been able to demonstrate the integration of machine learning into our tracking algorithms to show that these tracking algorithms can in fact be more robust. And you'll see this as a giant larvation Bathycordeus comes across another siphonophore, where we robustly continue to track that animal, even though we come across something else. But the point is that, thanks to the National Science Foundation for funding this effort, we've been able to demonstrate, machine learning and how it can have really strong applicability to these experiments. So for more detail about Fathomnet, you're more than welcome to visit this website. And I want to thank a number of different individuals and groups for their contributions to the work that I've been able to show you today. So thank you very much for your time.
Thank you so much for Kakani for that video. It's really exciting to see all of these awesome new sensing tools.